what's going on with these printers. Coming off of there, again, you can run multiple Z-axes. That printer over there and this one both have two motors in the Z-axes. When traveling, it's sometimes if one gets bumped, it can come out of whack. This model has a belt tying them together. Fred's model back there actually has a Z-axis off to the side with a plate, one single Z that raises the whole plate up. So you have X and Y. In this case, X is going across, Y is moving. I think actually all the ones we have here, X and Y is doing that. Some printers like a brand Ultimaker and the MakerBot, the X and Y stay on a plane. And it moves both directions. So not only X one way, but then the whole carriage can move in the Y direction. The plate stays solid and doesn't move. So that may lead to maybe better printing with a better quality. It changes the envelope. I mean, the Stratasys fits inside of a $70,000 box, has the plate there, and then the head moves around. Here, it's sometimes easier to just take a linear rail, some smooth threaded, some smooth rod. You can get it, McMaster Car online and move the Y-axis. It does add a little bit of extra inertia moving around, or a little bit of mass, leading to that. But it's much simpler. Speaking of the superset, here's an example, way too small to read from the back there, but what's one? Let's see, set filament diameter or storing the parameters. There's a couple of different M codes that add to the G code that are again specific to 3D printing. I'll try to summarize a little bit more here. So you have the CAD model. Doesn't matter where it came from. OpenSCAD, SolidWorks, Tinkercad, Thingiverse, scan it with a Microsoft Connect. Then it goes to the STL file. Important thing to remember whether you're creating the file or getting it from somebody or downloading the file. And that surface file then goes into either a slicer program and then a communications program, a host piece of software, or what they say is an integrated program, like Repetier, which I'm using here, is one program that does both. It really has multiple components, but to the user, it looks like one thing. And then to the firmware. So, see, the next slide says to make something. Now I think it's time to maybe get into pulling a model, exactly what I've been talking about, take something maybe from Thingiverse, slice it up, show you the code that's on the Arduino, maybe print something real quick. What questions do you have at this point?
Can you talk about some of the important relationships when you first load up Repetier? Like what things, because it has like some default settings when you go in there for printing out, what things like filament size and flow rate that you should pay attention to kind of get a better quality print.
Okay.
As you do it.
As I did that, all right. Is another hand here? Oh, yeah.
I was curious, how reliable are you finding the Arduino, and are you feeding the Arduino the code as it's printing, or is all the code, or you put in all the slicing and dicing before it starts printing and it just runs off of memory, or how do you handle that?
The Arduino is probably the most reliable part. Now in this case, this printer probably had an issue with a USB talking to it, or it's just bad luck. But this one does not have an SD card adapter, so I do have to run it off of a laptop. The Arduino probably is reliable, or whatever is on this embedded or integrated board here, and I had some electrical interference. This one, that one, Fred's, do yours have an SD card?
Mine runs from the
Okay. But others, like this one I do have plugged in right now to control it. That one was running headless off of an SD card. So the Arduino is pulling the commands right from an SD card, plugged into the little display, without the computer, and it's pretty stable. But I'm still tweaking on that one. It's a little bit more with motor currents, some resistance. These have belts. I might go off on all sorts of tangents, so keep asking questions if you to derail me or to find out more. These have belts. This is a GT2 bidirectional belt, a T2.5, not made for bidirectional, but works pretty well in a $500 printer. That printer has lead screws, or lead screws, like 10-star lead screws. So there's no belts on it. I actually found that there's a lot of moving mass on there that at the firmware level in the Arduino, I need to try to take into account. And that's something I'll try to remember to show you as well. So the Arduino itself, stable. The software side of it, tweaking the printer, getting to know, getting a feel of each one, that can cause it to seem unstable. And again, yes, actually communication issues can cause it to be unstable. But running off of an SD card, you'd be fine.
Are you powering that Arduino off the USB or off its own power supply?
This one is an older generation board that does need power for the board to run. These other two that are running off the Mega are powered up off USB, but the printer won't run without external power. So this one actually is running at 24 volts with a step down to run a couple other things at 12. So yeah, I can communicate with the board, I can program it, I can adjust things, I can tell it to start printing, and it'll just sit there waiting until I add regular power to it.
But you're running the electronics itself off of the USB.
In this case, yes. So when you're plugged into the computer, you can be, oddly enough, you can be plugged into both. This can be running, pulling information off of the SD card. I can still interject commands that say change the temperature. I can kill the printing from the computer. So it can come from both ways. When it's not running off the SD card, if it's just running off USB, everything is buffered. And that's what would happen if you have an electrical interference or a glitch, some communication issue. You start streaming some video on the computer that's running the printer. The buffer on the Arduino is very minimal. Arduino Megas, Unos, that generation is not fast, does not hold a lot of information. So it's very, very easy to have an underrun where then it sort of hiccups, or waits, or pauses. So you definitely, if possible, you want to have a computer dedicated to it or add on an SD card so you can just get the instructions coming right off the SD without a computer attached. And I'm going to go through some settings with Repetier. I got to show you some things in firmware. So, let's see. Okay. And let's see. This was the one that was attached to this printer. So I just printed a Yoda. Let's see if we can find another model. I think I'm on my. If we went to Thingiverse. So again, I mentioned Thingiverse. It's the easiest way to start. You can go in here, you can browse around, you can look at different collections, favorites. There's customizable things where somebody's created something like an OpenSCAD parametric-based design where, like these little keychains. The little weight keychain type things, that's a lithograph. That's the name of that. Yes, here we go. So I'm not too sure which one I used exactly, but I took the LV Tech logo off the meetup site or something, put it in Thingiverse, into this customizer. It's probably a good explanation for everybody here. Chose a file, uploaded it. Let's see if I can find. Yes. Sort of see that from right there. Chose a file, inverted it to make it relief. It say how big the hole was, what layer height I'm printing at, the number of layers. So now MakerBot's given me something on Thingiverse that makes it easier to have fun printing, which is really good. Because for the last 2 years, again, if you didn't know modeling software has something out there, some of the question was, what do I print? Now it's easy to, just in a few minutes, take a picture, a logo, a portrait, upload it to something, and create little trinkets. So that's one example there. Another would be, this is one I like, is Keep It Awesome. I don't know if there's a couple of those on the desks.
Yes, there are. And if anybody didn't get a little keychain thing, everyone gets a little keychain.
you didn't get one of these white little keychains and you want one, grab one. That's printing probably 40 or 50 of them. So I don't see the Keep It Awesome right there. I'll show you what I do. So I have a place where I go in, I find my things, and keep them downloaded. So this keep it awesome. If I open this up, I don't know how somebody created this, but I know it's a closed model. And it's just a block. Maybe somebody created in maybe SolidWorks. I have no idea. But that's what I was talking about, the STL model. From there, I can go into Repetier. Again, this is one of the host softwares that has the slicing sort of integrated with it. Go in, Thingiverse, there it is. Open that up. Now I have Keep It Awesome in this host software. I can position it, I can scale it, make it a little bit bigger if I wanted to, rotate it. Still want to rotate it that way. Anyway, we'll try to print it. Let's see. The next thing is slicing it. So this particular piece of software has two options, Slicer and Steinforge. In the Steinforge, in the open source community, you'll probably hear two of these. Steinforge is the original, very, very many parameters. You can control everything that happened. So remember, you're working with a model that is just a description of the outside. You as a user, you have to determine how to create it from the inside. And I think one of the biggest opportunities for anybody who wants to get into 3D printing and maybe make some money in the next couple of years is software people. The hardware, if there's 450 companies out there making printers, not surprised. You know, after a little bit of time, you could probably make one in your garage too. The software side, though, that's smart enough to figure out how to print and when to cool down the temperature or to cool down the nozzle at the right time so Yoda's ears don't melt. So things don't warp. The software side has a lot of potential. So that's slicing. What Fred was asking about, you know, choices to make with Slicer. Here is one piece of software called Slicer, where I can come in and say, okay, I want to print this. Keep It Awesome. We have one. This one is at like 120%, and I want to print it at 0.25 layer height. And I want to make sure that anywhere there's perimeters, I want 2 perimeters so it's stronger. Anywhere there's top and bottom on the model, I want to have 4 shells. Because at 0.25 layer height, I want to at least have 1 millimeter top and bottom so it's reasonably strong. There's other parameters in there that will help keep the model clean, like trying not to cross perimeters. The infill, maybe I want to, I gave any jump pieces out. This was actually a piece that worked out really well. There's a hexagon infill. And, you can choose what type of infill. Random lines, zigzag or grid patterns, hexagon, and that would determine the strength of the inside of the part. Typically the fill density doesn't have to be that great. When you're printing gears or something strong or a rigid part that, you know, maybe it's not a prototype, maybe you really need to use it, you go a little bit higher density. But fill in plastic means heat. Heat means, well, the heat stays and then the next layer gets too hot, previous layers don't cool down. Heat also means in ABS, shrinking, you know, maybe not uniformly. So you want to keep the fill density down to save money on plastic, lower the amount of time it would take to print it, and avoid any heat issues. Other parameters, if you're printing real low layer heights, you can maybe infill every other layer, so it's not, to get to print faster. Here you can choose speeds. I can run this printer maybe at 30 millimeters per second and get some nice printouts. This one at maybe 50 to 80 millimeters per second, so sometimes I can print nearly twice as fast on this machine. It's a little more rigid. It gets back to being the educated consumer. If you find something like that, something like this around the same price, It might be a little bit odd because, first of all, 80/20 is very expensive, but this machine is a lot more rigid. You'll see people getting rid of these, maybe on eBay for a little bit, less money, because the iron mine's pretty strong. That's not as strong as the 80/20 or something like that one, which is, what's that, 3 80/20s, sort of side by side, and also weighs about 60 pounds. So speed is also has a lot to do with how the printer is constructed. A MakerBot in that box shape, using the gantry and the X and the Y, can print rather fast. Threads, once we get threads working, feeding the filament right is going to print very fast because his extruder is off to the side, feeding the filament through a tube. So it removed the mass from the extruder, put the motor to the side, and now instead of pushing through the hot end, it's pushing through a tube into the hot end. Lower moving mass means prints faster, less vibration as it comes around a corner, less ringing, nicer looking prints. Again, different speeds here, 60 to 80 millimeters a second. When it gets to the corner and tries to turn, you can get a little bit of a ringing look. So sometimes people want to run at 30, 40, 50 millimeters. Let's see. There's a skirt and a brim. Things want to warp. Brim is a setting that you would use to add something around the bottom. Right here with the brim. Maybe something might be floating around with the brim. This is the part that warped. Didn't have any brim on it. Probably had the wrong stuff in the to hold it down. But you can print an extra couple millimeters of plastic around parts that help hold it flat. So if you're having trouble, if you do a printer and you're having trouble with warping, adding a brim can help you there. Support material on the outside. Yoda, this print of Yoda actually came with a little chin support somebody added in the model. If it wasn't added in the model, you can turn on support that may determine whenever there's an overhang past whenever you determine 45, 60 degree angle, it will build a scaffolding up the outside that you can break away. All the printers in here, spreads will probably use two materials soon. But these printers using one material don't have that second material to be a support material. So you can't have it build this scaffolding that will hold up parts so that Yoda's ears don't droop. It doesn't look like he has an earring in. That scaffolding, you come up, you print the part, it comes off, you break off that scaffolding, maybe clean up your part with a razor blade, and it helps you accomplish those things. And then there's also a way to adjust the width of the extrusion. The whole topic here is, since it's like a hot glue gun, the printer needs to know what's going in. And if it knows what's going in, it has to know what's coming out. So it's volumetric extrusion, which basically means if it knows that if you say extrude 50 millimeters up here, 50 millimeters goes in, you know the volume, you know it must come out the bottom. So the software sometimes doesn't even really care how big the nozzle is. A larger nozzle can extrude faster, and a smaller nozzle may be limited, so it extrudes smaller, a little slower, but it also lets you get some more detail. So there's going to be a compromise. If you want to be prototyping big parts and you have a really small nozzle, it's going to take forever. So pi r squared is the surface area, right? Can I do my math? Pi d's, so pi r squared. So the larger the nozzle, the more volume you can get out. If you want to print something really big, large nozzle, something really detailed, like trying to get Yoda's eyes really right, small. But that has to do then with, if this is running at 0.5, now we're getting really deep real quick. Does anybody have questions at this point before I go too deep?
What utility is this that you're using?
This one is Slicer. This is a slicing software that's linked to Repetito. So, one question, just going to draw real quick. Different than like a hot glue gun. If this is the nozzle and plastic is coming down the inside, if this is 0.4 millimeters wide, and you want to extrude something 0.3 millimeters, that's not as wide as this, it has to stretch it out. So the plastic would stress, warp, maybe look thin. At the same time, if you want to extrude something real wide, it's sort of like smashing your toothpaste, across your toothbrush. You can extrude 1 millimeter wide. Now again, you're stressing the plastic. You can cause warping. So one of the first things with configuring the printers is to know the nozzle size. If you have a 1/2 inch or a 1/2 millimeter opening, the volume coming out of there when it prints basically comes out in an oval. And then as it comes along and prints me the next perimeter next to it, it's going to be another oval. They're then going to bond, additive upwards. So the next time they switch a layer, you come along, it's going to create another oval. This section is what's holding your part together. So in ABS, you're running at 220 to 230 Celsius. In POA, you're 180 to 200 Celsius. This melting to this one is what's really guaranteeing that your part doesn't delaminate, is what's putting it together. So this is important, like if you have a 0.4 millimeter nozzle and you want to print 0.25 high, you want that volume to come out nice and even and smash. If you want to print at 0.1 millimeter high, it's going to be real thin. You might be stressing that plastic. A little bit of a tangent there, but extrusion width, you have complete control over that. One of the parts, a couple of parts around here are at 100 microns, so 10 layers per millimeter off of, I think it was this printer off of a $1,200 printer, which is pretty amazing. You can almost make molds with that.
I mean, the temperature of the bottom layer is very important. Like if you're printing a big piece, it's got to be a longer time before it gets to the next layer, so it's going to cool more. Or
There's a lot with temperature. ABS warps if you cool it the wrong way. Real pain in the butt. Like set out to conquer it. PLA, on the other hand, you could have a big desk fan blowing across it and print better. So depending on the plastic, you want to control these temperatures as well. If you're going to start with printing, I would probably suggest going with the PLA. Your ambient temperatures, your air passing around, drafts, just looking at the part, breathing on it, you're not going to cause warping. This one has a little blower fan mounted behind, and as soon as it prints, you want to cool that plastic, get it through its state change, and get it bonded to the layer below. If you blow ABS with any air that's less than 70, 80 degrees Celsius, you're going to cause the ABS to shrink, not go through a state change. And it's going to cause incredible warping, cracks, and it's going to be a real hassle and pain. So back to different layers. ABS, you're going to want a hot bed. You're going to want to keep the part warm. Heated enclosures are patented, but you can build one yourself. Just don't sell it. Now that Stratus has bought MakerBot, you'll probably see heated enclosures on the MakerBots. The Stratus owns the patent. That would help the ABS stay a little bit more informed. Again, with POA, as soon as you lay that down, you want to be blowing air across it, take it through a state change, set it in there nice and perfect, and get some really nice prints. And you can print at room temperature without a heated bed. ABS, you also need a heated bed. Jumping all around here. So, some printers you'll see come with or without a heated bed. If you're going to buy one, I would say go ahead and buy one that has the heated bed already on it. That way you wouldn't have to rewire it or retrofit something. It would give you that option to print ABS later on. But POA, like all these little white LED chains, printed on blue painter's tape. Just plain old roll of blue painter's tape sitting on top of the glass, edge to edge. The plastic will stick beautifully to that. And again, you're cooling it before it works.
We're getting close on time, so if you want to just focus on the questions, and you guys have any questions, are you going to print something?
That's up to you guys. I mean, it's...
Yeah, if you want to start the print, just wrap it up, and then any questions and answers before we have to head out of the venue. So we still got like 20 minutes or so.
Oh, okay, sure. Okay, but we definitely, I guess you want to see some of the Arduino side. Look at the firmware briefly.
Yeah.
Okay. So let's see. All right, back to real quick. There's filament settings. You got to know volume. 2.84. Measure your plastic. Measure it 4 times in different places, average it out. That's your diameter. Don't measure it once. Because plastic, as it's on the spool, can be an oval. Measure 4 times every 45 degrees. Average it out, and you just use that as your diameter. You don't have to get more complicated than that. And then the printer settings, between moves, you can retract the plastic, stops oozing. That one I don't even retract. If you can move the print head fast enough, the plastic that is continuing to come out. You can picture if you squeeze a hot glue gun and you stop squeezing it, or you squeeze a caulking gun and you stop squeezing it, guess what? Caulk still comes out. Hot glue still comes out. Same thing happens here. If you stop extruding, just the heat alone will cause plastic to ooze out. So there's a bit of retraction that has to be thrown in between moves. So if you're extruding plastic and you want to move over here, pull the plastic back up, move, again extruding again. A lot of those parameters will make your print look better. So discard, and after you figure out all those parameters, either consult with somebody or go through a couple days of torture, a couple months. So then you can click on slice. That's 23 minutes. That's a little bit long. So I take this down to 1. Slice it again. This software calls the slicing software, brings the code back in, and then we can see it on the right side. If we started now, I guess we can let it run for 20 minutes. Hopefully it'll be fine. So this is the G code. It says my parameters are 0.5, and there's all the parameters all commented out there. And basically in the beginning then is some homing, and then it starts moving. From X to Y, extrude this much. X to Y, extrude this much. Look, change layer. Move in the Z direction at this speed. And then we said the extrusion, start extruding again. You see the complete code for something. This software, the reason I like it, you can easily slide through and see what are the different layers look like. Looks like it's going to print, I hope. And one thing that you do, if you have control over it, is prime it, just like you would with a hot glue gun. You need to get some plastic going through, so you need to prime 10 or 20 millimeters first. What it does is create a back pressure sort of inside here. If this is sitting here hot, it just will begin to ooze out, and when you go to print, you have to create that pressure. So now you can prime it. I touch it with my fingers, but probably want to be a little more gentle, and then maybe take the other off. And right now we have, since it's ABS, I have the extruder at about 220. The print bed here, take that up to 100, a little bit higher. 100 Celsius is a lot, but the reason I say to go with PLA first, getting ABS to stick to something is the real pain. MakerBot, some of the others you can print to an acrylic. I have no luck with printing to acrylic. When I print to it, it doesn't come off. So I've tried different materials. I'm now on using Elmer's glue. It's a new material instead of acetone. Glue stick. It's PVA plastic. PVA plastic is one of the plastics that people do print out of. And some with a brain after all these years in the rep group finally realized that that's what's in here. So instead of trying to make your own, you can put this on at room temperature, and it helps the ABS stick to the surface. The other option is using like ABS juice, which is ABS dissolved in acetone, which works really well, and it also is very flammable. So, definitely don't want to travel with it. Don't leave it in your car. It will pop open in your car, and your car will smell like somebody left jewelry cleaner all over. So here we go. Hopefully it sticks. The most important part is always the first layer. If you don't get a good first layer, you might as well turn it off, start again. In my case, what I do is I keep the layer height, first layer height exact. When I measure and I calibrate, some people calibrate it so you get a sheet of paper underneath the nozzle. I don't do that. Mine is exact. There's different ways, different styles of calibrating. If you buy one and go on forums, you'll find different advice. But I have it moving up, so right now it's doing the first 0.25 millimeter layer. In the software, and the reason I like Remetier, all open source software isn't showing, the path that it's drawing right now. So if I wanted to, again, I can go through the G code and I can look to see what it's going to do next. At layer 1, that's what it's going to create with a brim on it. At layer 2, that it will create that. A couple layers in, it goes hollow, does my infill. A couple more layers, it says, oh, we need the top, and then we got to draw words on top of that. It doesn't know the words, it just, remember, knows there was a shell that was described, and it has to fill it in somehow. The EEPROM, or the Arduino side of this, we see in two different ways. One, in Remetier, you can see some firmware settings. There, for stepper motors, there's steps per millimeter, there's feed rates, there's acceleration. In the last part of that tool chain on the PowerPoint, you saw it was the firmware. So you've got the STL model, you created it somehow, you get an STL model, you put it into a host piece of software, it goes into a slicer where you play with it, figure out what's the best way to draw it, and then it goes to the Arduino. The Arduino has, here, I'll show you just the configuration part, not even the software side of it. So here's a configuration file that you would upload for the firmware with the Arduino. Variables, comments, define the motherboard, say what type of power supply. We got, one temperature sensor for one thermistor, PID tuning that makes sure that the bed is heated or the thermistor is heated according to smart tuning, not just on and off. Which way your end stops, there's all little switches and end stops, which way the end stops are configured, and then we have acceleration. So this is the section, and if you really want to push the printer to run faster, or you're having trouble with, you can look at this section. It's the, remember I said about it being volumetric. Here's the steps per millimeter for the plastics extrude. So if you say extrude 25 millimeters or 50 millimeters and it doesn't, you change it in the firmware. If you find that the printer is binding up, you can't take a maximum speed, you can go into the firmware and change the maximum feed rate. You can change the acceleration. You can change a jerk, which is actually a jerk, not a real thing, but jerk is when it comes down to a corner and makes a right angle, what speed should it be at before it makes that turn? So CNC people know that term jerk, but that is sort of like a decelerate to the corner and get out of the corner. The
Derivative of acceleration.
what's that?
The derivative of acceleration.
Is it? So, all right. I just know that if it's too low, they can't make it around the circles. It's always trying to slow down and start again. If it's too high, you're flowing in and out of the corner, and then the stepper skips, or you lose a step and your parts off. So it's a fine balance between all these things. As well, in the software,